Welcome back to our show of learning algebra. So far we have learned a lot about numbers, and before we move further, let's see what we have learned so far, and from there we will go to our next learning chapter. Let's see what we have learned here. We have learned number systems, we have learned about integers, we have learned about positive integers, negative integers, whole number, and we talked about sets, we talked about collections, we talked about what a set is, what is integer as a set, as a family, and then we talked about impact of putting a sign in front of a number, and we talked about if there's a positive number, or if there is a positive sign in front of a number, we can drop that positive sign, and if there is a negative sign in front of a number, we cannot drop it. We also talked about the rational numbers family. Rational number family is any number which is divisible by which can be represented as x divided by y, and wherein x and y both are integers. We talked about irrational number, the numbers which cannot be represented as x divided by y, where x and y are both integers. An example is our Pythagoras number, square root 2. And more examples are pi, more examples are square root 3, square root 4, not square root 4, sorry, square root 11. And then we talked about absolute value of a number. Absolute value of a number is the magnitude, the mod, the power of a number. So minus 5 mod of that is actually greater than mod of 2. And then we saw what the prime numbers are. Prime numbers are the number which are not divisible by any integer. When I say divisible, they do not result into an integer when you divide by another integer. For an example, if you divide 5 divided by 2, then you get 2.5. You do not get an integer. So 5 that way is a prime number. We also saw what the even numbers are. Even numbers are the numbers which are divisible by 2. When I say divisible by 2, they are completely divisible by 2. So let's take an example. Number 16, if you divide by 8 or divide by 2, you get an answer of 8. If you take number 14, if you divide by 2, you get number of 7. So these numbers are even numbers. But let's say if you take a number of 17, if you try to divide that by number 2, you do not get an integer as an answer. As an example, if you take 11 and if you try to divide that by 2, you get an answer of 5.5, which is not an integer. It is a rational number. And we also looked at odd numbers. Odd numbers are the numbers which are not divisible by 2. And when I say not divisible by 2, means when you try to divide them by 2, you do not get a complete integer. So 17 was an example, 11 was an example, 5 is an example. Let's see our next topic of discussion. Our next topic of discussion is balance. Algebra is about balance. This is one of the golden rules of algebra. It's about balance. We try to balance things in algebra. We try to balance things in our life. Solving an algebraic equation means you're trying to balance it out. And when I'm saying that, I'll show you what exactly it means. Let's, even before explaining that term, see how can we put an example about this. And again, as I mentioned, this program is about an effort. This program is about making sure that the fundamentals are clear. This program is about making sure that we take you from the grassroots level. So in order to make that effort, we have to take some real life examples, right? So let's take our very basic fundamental example where we are trying to add two numbers. You remember this example, -2 plus 5 equals what, right? And then we said you can say -2 plus 5 equals 5 minus 2, and answer was 3. But how do we solve this thing in terms of balance? How do we derive balance out of it? And how do we interpret, how do we look at expression in terms of balancing it out? That's what our effort or this example will be all about. So let's see this example. -2 plus 5 equals what? And we will now take you to one of the examples from physics. See, that's the beauty about this program. We are not just restricted to teaching mathematics or teaching algebra to you. We will be talking about a lot of concepts from here and there, and in that effort, I'm sure not only the algebra part will be growing up, you'll also get some of the basic fundamentals of how things in science, how things in real world, they behave. So, and I hope with this effort, when you come to actually learning those concepts in your classes about, for example, physics, those concepts will be much more easily understandable to you. So let's see what example we are talking about. Let's imagine we have a scale, and this is our famous scale. The green part represents the positive number, and the red part represents the negative numbers. And the two circles which you see, they are called pulleys. They actually move, and red bucket on the left hand side is a bucket where we can put some weight, and as soon as you put some weight in that, the red bucket goes down. And as soon as you put some weight in the red bucket, as the red bucket goes down, the green bucket goes up. And as you put weight in the green bucket goes down, the red bucket goes up. That's the simple physics example we're trying to show you. And this will also hopefully show you some example of how pulleys behave in physics world. So when you will be learning about the pulleys in physics world, you will remember this example. So I hope the concept level things we are growing well. So let's see how we are solving this equation. -2 plus 5 equals what, using this our physics example. Now we have to add a plus 5. Even before adding plus 5, let's think about the behavior of this pulley. And behavior will be such that when we put one pebble into pulley, the pulley will move down 1 unit. So if we put one pebble into the red pulley, the red one will move down 1 unit, and the green one will move up 1 unit. Similarly, if we put one pebble in the green bucket, the green one will move down 1 unit, the red one will move up 1 unit. So we have to add plus 5. So we have to get 5 pebbles first to add. All right, here comes our first pebble, our second one, third, fourth, and fifth. We have got 5 pebbles. Now what we are doing here is we are putting these 5 pebbles here. All right, what should be the behavior? As we told, the behavior should be that the green pulley, the green bucket should move down by 5 units. And as the green bucket should move down, the red bucket should move up by 5 units. All right, here goes the effect of putting 5 pebbles in the green bucket. Now, what we have done here is we have put plus 5. We have added plus 5 to our whole mechanism here. Now in order to solve minus 2 plus 5, we have to add minus 2, but before we do that, let's see the green bucket which has moved 5 units down here. Alright, next step is add minus 2, which means we have got 2 pebbles on the left hand side. If you see that, we have got 2 yellow color pebbles on the left hand side, and what we will be doing is we will be putting those 2 pebbles in the red color bucket. Here we go, we put the 2 pebbles on the red color bucket. So what should happen here? The behavior should be that the red bucket should move down 2 units and the green bucket should move up 2 units. Here we go, this is our mechanism. So what has happened here is the effect of adding 5 pebbles on the green bucket has been that the bucket moved down 5 units. The effect of putting 2 pebbles on the red bucket had been that the green bucket moved up 2 units. Now the dark line, straight line, which is on 0, that shows where our buckets were originally. So the green bucket is still not at that point. So where is the green bucket? The green bucket is 3 units still down from our 0 line, which means the effect of putting 5 pebbles on the green side and the 2 pebbles on the red side had been that our green bucket is still 3 units below our 0 line, and that shows how did we solve it. But wait a minute, we'll use some more ways to solve the same equation. See, this is our bar, green bar, which tells our first motion, the magnitude. You remember our magnitude thing? The magnitude of motion in our first move, when we put 5 pebbles in the green bucket, was 5 units. See, that's how you will now learn what is the importance of understanding those terms which we talked about in numbers. Now you'll see what is the importance of understanding magnitude. So regardless whichever direction we are talking about a magnitude. The magnitude by which the bucket moved down when we did put 5 pebbles was 5 units. And the magnitude, the red color shows the negative sign, the opposite direction, but still it's a magnitude. The magnitude by which, or the absolute value, or the mod by which the green bucket moved up in opposite direction when we did put 2 pebbles on the red bucket was 2 units. And the blue color bar tells the magnitude, the result, the absolute value of resultant which we get by subtracting 2 from 5. So the result is minus 2 plus 5, our blue color bar, which is 3 units. And with this example, we are able to solve minus 2 plus 5 equals 3. See, that's how we saw it. I hope with this example, some concept of balancing has been clear to you. Now, we'll be talking more and more about balancing. We are not done yet, because this algebra, this whole series is about balancing. So we'll be using examples from balancing again and again, again and again. Let's see. This number operation, minus 2 plus 5 equals 3. And what if we did not know 5. Let's say we come with the expression minus 2 plus n equals 3. See, now we are trying to be little more advanced in learning algebra. We are trying to solve an expression, and you remember what the expression was? Expression is where you have something to solve, where you do not know the answer and you have some complex combination of numbers and symbols, and then you want to know what the value is. So minus 2 plus n equals 3, and we are trying to solve what the n's value is. So let's see how do we solve it using that balance example, or how do we solve it using our example shown here. So we have a bar which says minus 2, which has a magnitude of minus 2, and then we have another bar which is of height n. We do not know what is n. We have to solve for n. And then on the right hand side we have another bar, blue color, which we know the height of that bar is 3 units. You remember the example which I gave in the beginning of this program, whenever you're trying to solve for algebraic equation, and whenever things change the side, they change their signs. Now, how will you solve for n? The way you can solve for n is you have to move minus 2 to the other side, and then see when 3 and 2 become and join one big number, that will be the magnitude of n. Here 3, did you notice one thing? Minus 2 changed its sign. It was minus 2. Let's do this part again. Minus 2, when we move to right hand side, it changed the sign. So now we have got 3 and then plus 2, which becomes equal to n. See, this is how we solve algebraic equation. So what we are doing here is not only we are solving algebraic equation, we are balancing it out, and then I'll show you how we are balancing it out. Don't get worried, don't get nervous about that part. But just for the time being, remember how we are solving. So n becomes 3 plus 2 equals 5. So what we have learned here, it's all about balance. It's all about balance, balance, balance. You see that? In our real life, we have a lot of examples, a lot of scenarios where we use balance. First, on the first right hand side, we are seeing two people doing a seesaw balance. On the top left, we have an actual balance where we are weighing two things, two fruits, and the bottom picture, someone is trying to balance two objects. So this is what, and this is how algebra behaves. We try to balance things, and as soon as we are able to balance things, our equation is solved. And we will see that. We will see here how to balance the equation, how to solve the equations. This is our first rule, first golden rule of algebra. It's all about balance. If you must have seen seesaw in the real world, right? And let's say if you put one object on one side of seesaw, the side on which you have the object goes down. The side which does not have the object will be up. So this equation is not solved. This seesaw is not balanced. Let's see how we can solve it, how we can balance it out. We dropped one object on the seesaw, and the seesaw is now not in a straight line. The only way to make it straight is we drop another object on the other side of equal magnitude. You remember the word magnitude? Always keep on remembering these words, keep on using these terms. That's how you will master these terms, you will understand these terms. We are talking about magnitude. On the seesaw, on red side, on the right side we have a green color ball, and on the left hand side we have a red color ball. Both the balls have same magnitude, and as we drop two balls on the seesaw on both the sides, the seesaw is balanced. This is called algebraic equation is solved, and we'll come to that. So let's take an example, or our favorite example, -2. This time I replaced n with x because we want to give you a understanding about what algebraic equation is not about. It's about using a symbol and then using that symbol with some values. Replace those symbols, you have to get that concept. -2 plus x equals 3 is actually the same equation as -2 plus n equals 3. In one case we are solving for x, in other case we are solving for n. Now n equals 3, x equals 3 will be actually same thing. So we have our seesaw here, and the way to show you this expression -2 plus x equals 3, we are taking minus sign with something which moves up in regard to the gravity. So one of the example be few balloons which move up, and let's say we put two balloons which will move seesaw up by 2 units, and on the right hand side we have got three actual weights which will move seesaw right hand side by 3 units. Now see what is the effective weight or effective force on seesaw, which we have to compensate for, or which we have to put on either sides to make the seesaw balanced. Now if we put 3 weights on the left hand side, we still will have 2 balloons, so our seesaw will not be balanced. We'll have to actually put 5 weights. Now there is one assumption which I am making here. One weight unit and one balloon's magnitude, the absolute power, are same. So if balloon is tied to 1 unit, it will actually not move anywhere. The weight and balloon, they will compensate for each other. So just to take that example, if we put 3 units of weight on one side of seesaw, if we put 2 balloons on another side of seesaw, in order to balance it out, we have to put 5 units of weight. That's how we solve the algebraic equation. That's how we come to know that x equals 5. So that gives our first rule or first tip, that any equation performed on one side should also be performed on other side. So if we are let's say if a balance was there, it was completely balanced, and if we are putting 2 units of weight on the right hand side, we have to make sure that we put 2 units of weight on the left hand side also to make it balanced. And until we do that, our balance will not be completely balanced and our equation will not be solved. So it's very important for us to remember this tip, that any operation performed on one side should also be performed on the other side, and we will be using this tip a lot to see how we can solve our further algebraic equations. Now we are using one more symbol which is called equals sign, and we have used that symbol in our previous slides also. I did not get a chance to explain or show about this symbol, but whenever you see a symbol with two horizontal bars in our mathematical word, that is called equals. So 2 equals 2, 5 equals 5. You remember we talked about the arrow symbol on pointing towards the right hand side? That means one number is greater than other number. The number towards which the arrow is pointing, that number is lesser. The number from which the arrow is going is bigger. So 5, then arrow sign 3 was meaning that 5 is greater than 3. So here this symbol with 2 lines means our equal sign. We are saying our left hand side equals our right hand side. Now in our second picture, when we are putting a weight x, we do not know what is x, but whatever amount of weight we are putting on one side of balance, the tilted towards that direction. Balance is not balanced. As soon as we put the x on the other side, the seesaw gets balanced. See, this is our tip. This is our first golden rule. We have to remember, whatever operation we perform on one side, we have to perform the same operation on the other side. And until we do that, our balance is not balanced. In our coming slides or in our coming classes, we will be solving for algebraic equations using this balance, this golden rule. And I'm sure by this time you're also growing and learning. And in our next classes, we will be talking more about that. I'm getting a signal. The time is going up. We'll be seeing you in our next class. Thank you.